So, hello and welcome in new video. Today, what we'll talk about is the app that I made. It's available on Linux and on Windows actually. It is totally completely different app on both platforms. Now, if we go to GitHub, now this is the app I'm talking about. I don't think I committed latest and greatest from today. No, I didn't. The app is Fan Commander for Windows. I also made Fan Commander for Linux, which is this one. And yeah, in terms of Linux, it's working nice. Now I ported it to Windows. You can see my previous stream where we was fighting with CL linker. At the end, it took most of the time. I was doing some optimizations which AI was incapable of. And here's the Windows version. Yeah, I need to throw out this and make some stuff git ignore. Yeah. No, don't sue me if I have some precompiled shit in there. I might make this thing private. Meanwhile, I clean the repository. Yeah, FanControl and Nano I need to throw out. On Windows that thing doesn't work. It's basically the driver, so you can add your own fan controller. It's not even the latest I made. This one doesn't work. Anyway, now the app on Windows is extremely efficient, because you will ask me most likely, why would I use your app? Because basically my app is made for to be suckless, to be I don't wanna say to be easy to understand, because most likely it's not. I kinda use C philosophy when writing that. I don't make functions or methods like if they are not needed. And now, to demonstrate my app, let's see how our configuration file looks like. This is how our configuration file looks like. Basically, the app will go and parse sensors and stuff from Libre Hardware Monitor, and then you need to put here correct sensor name and sensor. Like if it's a CPU, then you need to put CPU in a name anywhere, because it basically searches for CPU wording. Like it doesn't matter if it's CPU, I don't know, 1 billion or something, basically needs to have CPU. If it's CPU, if it's GPU, it needs to have GPU. For now only CPU and GPU sensors are supported. Meanwhile, all fans are supported that are at least on NCT Nuvoton platforms, with which Nuvoton makes most of the built-in motherboard fan controllers, and maybe even others. Now, what actually you need to put there, you can find in so-called event viewer. Basically, when you run an app, you will see such output. And what that thing does is basically tells you what sensors do we find and what fans did we find. Now, as you can see, we could use core max, core average, whatever. Like, it finds the CPU and GPU. That one needs to be here. Very easy to configure. Now fans are just numbers. I found 7 fans from 0 to 6. You can see then basically here is temp sensors array, here is fans array. Fan control index 3. This is our fan 3. Now which fan is which? I don't know. You can have third-party software to do sliders and map them in your head. But I basically know the control one is CPU, and maybe you can set custom values in BIOS fixed, and that way you can recognize them. Like if one fan is spinning faster, like when it's not controlled. This is before they are controlled, so this is basic. These are basically values that we find this one time, and you can see some of them are 0 or hidden headers. I don't even think there are any additional headers on my motherboard. These are hidden ones, looks like. Yeah, and found my GPU and 2 sensors. Now here is graph array. You populated how many values you want. These are linearly interpolated. PWM you need to set here. It's from 0 to 255. Now if it's like I could make these one percentages. I do not have linearization of fan responses built in yet, but it might be the next feature. Anyway, it's not needed. Like if you will need to tweak, even if there is linearization, you will still need to tweak. Like some fans act like sound differently in different levels, and I would still need to tweak them in an app to make my system sound the best and cool how I want it. Now here is for GPU. You set graph for this sensor. Like you can have, of course, then these graphs that use sensors, you link them to basically these ones here. And yeah, and device index here is the which device, like if you have multiple CPUs or multiple GPUs, which order by order you set which device in a array of your found devices is this one. Now in my case I have only one, which is visible here. Like we only have one CPU output, one GPU output. But if you had multiple, you would set, for example, one index for CPU and for next CPU something else, and then okay, you know how to do that. Here is refresh interval, one sensor read per cycle optimization. It's good to set that if you don't have too many sensors, because we are single threaded in terms of that thing. Basically you can have that on true unless you have like bajillion of fans. Now here are the fans. Fan control index, fan RPM index, usually they are the same. You can basically run the app with test fans and or TF from your terminal, and it will actually print out in event viewer the connections, which sensor corresponds to which fan. So I mean sensor, I mean PWM sensor, you know, RPM sensor, my mistake. Which RPM sensor corresponds to which fan. Here we assume the same number is connected with the same control for the fan. And yeah, in my case it is. Like, but if I showcase, of course, let me showcase. let's close that app and let's run it with TFC TF test fans, and C is for continuous app continue to execute. You use TFC if the app is already has configuration file done, so you basically configured everything. Unless if not, then you only use TF and the app will finish as soon as it prints out the data. And we can see that, of course, you need to run it with an administrator. Now our app will basically do sets of tests. Like, I don't know, if we watch RAM usage, maybe by that we'll know when it finishes. I mean, it will finish very soon. You will see event log when it does. For now, I don't think it did finish. No, it didn't. There will be new event log. No, it basically tests. Oh, okay. We did finish. And we can see here trying corresponding sensors. Fan 0 matches RPM sensor 0 against testing control index 1 against feedback index 1. Okay. Fan 1 matches RPM sensor. Basically, that's important that it matches. Skipping fan 3 matches RPM sensor 3. And some fans are skipped. Basically, I see there is a little bit of it's not really sorted as I wanted it. But okay, these ones with these hashtags are basically telling you that fan matches. Now, if it matches some other, then it will say fan 3 matches RPM sensor 4, for example, or if it will match 4, like it tests which one match. And now this is it. And now here you have a couple of features. Here you map sensors to fans. You can have also multiple sensors per single per same CPU. Of course, these names here needs to be different, so they can be, of course, uniquely matched here. CPU, GPU, you match them, like you link them to fans. Sensor functions, minimum, maximum, average can be used. Usually maximum used, so you spin fans as by the hottest device. So basically between GPU and CPU, the hottest device will be picked. And average sample size. This is basically averaging of values in an array of 20. Of course, after app is running long enough, so 20 samples are available. So there will be always 20 last samples available, and these will be averaged. This kinda smooths spikes and stuff. You can also turn that to 0 and it will be skipped. I will most likely also make these configuration files better. For now, all of the values are needed except these ones. We'll come to that. These ones you can omit. Minimum PW, of course, these ones are how you want them. You can have more of them, you can have only one, you can have less of them, can have a billion of them if you want, if you have time to write them. Average, no, minimum PWM. How are my loudness levels on OBS? Okay, we are good, probably. Minimum PWM and start PWM are your set values of PWM so mm, basically your PWM start and minimum PWM wanted values, but if you can set them higher, but if real minimum and start PWM values are different, you can basically set them to 0 if you don't know uh, what your minimum and start PWM values are. You can set them higher value, like I have set them a little bit higher than the real ones. But if you set them lower, you can't kill your fans, because software will actually, when you start it first time, will actually map the correlations between PWM and RPM. As I said, not for linearization. That's maybe future feature. Basically, it will also check minimum and start PWM values. Basically, the values like at which when from turning standpoint to like stopped, at which point the fan stops, and the which point fan starts from stored state. And maximum PWM, you can set that like what you want. App will also calculate maximum PWM. You can overwrite maximum PWM like I had here. So if you know, because some vans like Intel specification, like it's some kind of old school specification document thrown somewhere in the internet, where Intel fans on like I don't know, over 220 PWM values, it's too smooth of a PWM signal, and actually fans act as they are DC fans. So it's like a feature when PWM is like almost continuous. They like act as DC fans, and RPM response from these fans then gets somehow broken. Actually, I have one fan that I tested things with. It's a Intel one stock CPU cooler fan, and that fan acted funny on my controller from Raspberry Pi. But if you use it on motherboard, it might not act funny. And on motherboard, most of the motherboards, you can override maximum value and like put maximum PWM in. And if you have really good fans, like I have I have what are these? Be Quiet, and I have Noctua cooler on my CPU with Noctua fan. These are all great fans, although I don't control a CPU here. And on output fan, I have some cheap DC fan. But usually your controller will manage overriding max value, and you can get even additional speed compared to even BIOS, because BIOS is following specifications, Intel's ones. You are not following any specifications here for max PWM. Like if you don't override max, then I will calculate max, and calculation should be accurate. For now, at least, I have limited machines which can test that on. Maybe I have bugs for my max PWM testing. Like it's pretty ridiculous what I wrote here for max PWM. Like where are FanControl? Okay, down there. Write mean start PWM. Okay, this is max PWM calculation. And yeah, it's very ridiculous what I wrote here. But it was needed because like sometimes it was looking like fan plateaued or even gone to lower like RPM, but it didn't really do that. So I probably wrote overcomplicated logic here because I think I could have just put this. I don't know. But this is run only once. Or if you change some values in read or in config file, then these things will calculate. Now, spin up delay. This is new feature that I added today. Even no, tomorrow. Spin up delay. And I mean previous day. Whatever. I'm English. God damn it. Uh, uh, and spin up delay. You can basically set delay how fast the fan will react in that certain PWM region. For how many seconds? As you can see, I have 7.5 seconds here set, and it will take roughly 7.5 seconds to fan to spin up when things change in so temperature gets higher. Meanwhile, if it needs to spin down, it will make that immediately. Also, I have an additional range here on higher values, and on higher values than 170 to, of course, the maximum is 255. Here it will use no delay, so it will be immediate. Of course, this is after averaging. You can set even averaging to 0 and only use that. Spin down delay is opposite. When fan is spinning already and temperatures get lower, you can make fan spin a little bit longer in that. So you can leave it spin a little bit longer in order to cool down your system more. Of course, these are made such way that when fan is in that range and it, for example, fallen PWM to, I don't know, 175, it will still be like counting down that time. But then when it goes under 170, it will use this time immediately. Basically, maybe for spin down delay, I could make it so it waits till these 10 seconds count out, and then it checks if it's in that range, and maybe, of course, it sets a new PWM after that, and then it checks in that range what is happening here. Because for spin up delay, you do kind of want when it's out of this range, you're fine to act immediately, because like you don't want it to be not spinning while your system has like I don't know, maybe 80 degrees or even more. It should be spinning like here it acts immediately after it's out of range, and here for now also, but maybe I can remove this feature. I was basically having it done that way without immediately basically waiting for this time no matter what for spin up delay, but I figured because spin up delay is very critical for cooling, it's better to be made the way it follows precisely these PWMs. So if after it's out of that range, that countdown stops and new value it's basically put to a fan, and immediately then these values are here used for the duration. For spin down delay, you kind of want it to spin even longer, even after it's cooled down under certain threshold. So maybe, I don't know, or maybe maybe you can make that thing here manually, like you put yeah, I don't know. Maybe ideally it's a feature, because still I can do that down to 130. of course remove that, and it will wait like 10 seconds, or maybe down to 0. It will not go to 0, but down to 0, like you can do 0, and then it will everywhere basically use duration 10 seconds after spin spin up, spin down delay, after it's cooling down, after your system is cooling down. You played the game, you closed it, and your system still has some kind of lots of energy in your board. Maybe CPU did maybe GPU did cool down, but you still have lots of heat in your motherboard, in your chassis, and it's good to cool it a little bit more. Like J2Sense used this feature on FanController. FanControl for Windows, the app, it's open sourced. And yeah, you can put that as this as many you want. You can have one. Now, proportional factor, we have proportional control. That's why I said previously we sample basically PWM RPM correlation. This is kind of used for if you built your system, you didn't clean it, it got really caked up, your fans barely can spin. I know it's extreme. That thing will basically put, if fans can't reach certain RPM that they reached when they were clean. I know, this is a ridiculous feature. You can put it to 0, and I promise it's turned off. It doesn't, like, the loop doesn't even touch it. Like, it's turned off. I did handle any kind of 0 as turned off. I do not calculate values. I do not divide by 0 and handle I mean, I'm not crazy that much, okay? So, hysteresis here, it's another one. Of course, as I said, any of, of course, some values you can turn to 0 and they mean something else. They are fixed values, like they are calculated and stuff. No, for hysteresis also you can turn to 0. That one you can turn to 0. It's totally handled. Everything is handled. Hysteresis, you can turn it off by turning to 0. And it's basically done. Also, it makes use of hysteresis to write temperatures less. So basically, write is totally skipped. Yeah, I doesn't just write the same value with hysteresis on. If same value is applied, basically, so it's in a range of hysteresis, then it will not do writes. But there's a catch. If you really want the best optimization, then just put proportional factor to 0. Now your hysteresis will truly not do writes, because proportional factor will affect hysteresis. Basically, hysteresis will still exist before linked. It's, if we would go in my software, you'd see hysteresis is of course before proportional factor. Proportional factor is closest to your fans PWM output, and the RPM output, of course, it needs to be how other would control. No, hysteresis, if you put that to 0, which I highly recommend because it's not really a feature. Maybe you can put that to extremely low value, and that way you will have really soft spin-ups. I still want to put some kind of feature for soft spin-ups, like calculating some exponential curve, maybe, for spinning up fans, so they are quieter when spinning up. Because proportional factor will not do that. I mean, we'll do that if you put probably astronomically low values here. It will be really, really touching your fans really slowly. But then the issue will be, you will have great error. It will never reach the desired point. This is the basically negative thing with proportional control. If you take PID control, which is the best, like there you have minimal error. Here you have constant error present. It's not too large. I have it set still because I'm testing my software, and I wanna show you. Like you can see, I didn't put spin up delay for my back fan. I could basically put that here and configure it. Now, what my software does, it's very efficient compared to like FanControl, which is C# written. My software is almost completely C++ written, which I have also make file for GCC, which I still didn't update, but I use CL compiler from Microsoft, which is most likely the most optimized for Windows, I would say. I mean, probably, I hope so. This is all FanControl logic, read JSON logic, header files, main file we have here, and then we have some hybrid kind of file. It is Libre hardware monitor bridge. That's what I did modify in my previous stream, and this is the worst file basically in the whole software. I mean, I'm not saying I did it the most beautiful way, like most modular way, but it's, I think, very modular because I transformed it to Windows very quickly from Linux, because I wrote it originally for Linux. And yeah, there might be still some things. I mean, I need to, like this file, okay, this file, it needs to be updated if we want other than CPU and GPU temperature readings. Like we want some SSD readings. We need to update that file basically. I need to update, or maybe someone has I don't know. Someone has some will. I do not have any merge requests on my GitHub page. I'm not that popular. I probably will not be. But if someone wants to make that software like I don't know, proper, maybe, which it is. I mean, to me it's proper. To me I love it. I love every single thing of it. Even bugs. I don't have such large ego that I will not basically let you do pull request and maybe do fixes and make it maybe more maintainable, even if you have, maybe these days AIs are popular, which I know that. I do use them also, but the app, the LHM Breach, it's kinda like 50-50 vibe code. Like, it's not really vibe code that I did touch almost everything. Actually initialize super IO cache and that for basically fan writes. That is almost completely vibe coded. It is tested, it works, and it is run only once, that part on initialization. I did tell it how to do it. Other things I did code by myself because AI was dumb, because I have free versions, I don't pay for AI. Is that a flex or something? I don't know. all of this, nothing is vibe coded. All is my code. You can see that by ridiculousness of it. I can see that I don't have enums here, which is okay. I don't care. It is validated to shit. You can't make it, I don't know, leak something. At least I didn't, I didn't test it that far. I didn't have any leaks, I might say. What I wanna work next is improve read JSON file, basically, so that if in configuration file you basically leave out some values, like if you don't use average sample size, maybe the 0 will be used by default, so it will not, it will still run, right? If non-needed things that are not really, that can be speculated, like min PWM, if you don't tell the app, maybe it's set 0 by default and then it's basically calculated. Max PWM, maybe it's set to 155 by default. And sensor function, maybe max by default, because let's be honest, everyone uses max most likely. I don't know, maybe. So it's easier, like if you leave out some things, it's not like not running. For now, I did do no newer things that I added spin up and spin down delay. These two I did such way that you don't include it. These are basically turned off features. Maybe I can do the same with these ones, right? And they are basically turned off features if you don't include them. Yeah, it's quality of life improvements that I'm planning to do. Now, in terms of building this app, I forked Libre Hardware Monitor because Libre Hardware Monitor doesn't let you write sensor. Doesn't let you write fan PWM values. That's why I forked Libre Hardware Monitor and wipe coded it, so it does that. It's not much, it's just functions that I exposed, that I can basically reach from like DLR libraries and stuff that are basically reachable, and I can use them in my software and change fan values. Of course, I forked that. Now, what it does need to be done now after Libre Hardware Monitor people update or add some kind of new hardware support. I basically need to just merge the new features with my, because mine shouldn't do conflicts, because these features are not included with Libre Hardware Monitor with a reason. It's monitoring app, it's not like app for controlling your fans. And why use Libre Hardware Monitor? Because it in a background they use basically Pawn.io to ring 0 driver to basically access all of the sensors and stuff. And so they basically use that, and everything is signed. This is an app that it will be not flagged by like Defender, so it's perfectly safe that way. Building the app, I wrote instructions for Libre Hardware Monitor here. How you build it for x64 platforms. And then after you build that, you have makefile and makefile. This one, GCC is not updated. This was my first one. Like, I could make it work because I did made it work. But for now, normal makefile, just put and make. You need to put all x86 compiled DLLs from Libre Hardware Monitor here. And then next thing you basically do in the folder that you create, it's called Libre Hardware Monitor folder. And next thing you do is basically compile the software against the built Libre Hardware Monitor. It will make some object files, DLL files, and it will put them into output. copy these output files. I don't know, I still need to write instructions. You put them in your, for example, program data folder, like these, and some of these, which ones are, yeah, these three are my one. And then also in the same folder you copy together this one, and don't overwrite the files that you took from here. For example, first maybe it's better way to put these ones into a folder where your fan commander will be, and after that copy these ones here and overwrite the same files with our new ones. That way that will work miracles, and it will work. Like, software takes minimum, like, we have very low usage and our sampling is like half a second, and that means 250, like quarter of a second. It's always sampling because I divide evenly. It's always doing some reads or something. Now, in order for you to believe me, my software works, I will now demonstrate first of all with extreme test. Keep in mind that fan 2 will be delayed, kinda probably. I mean, how quickly it will be kept. Yeah, you can see our fan 2 is delayed because of that delay that we have set. And it did ramp up. I don't control CPU with my app, I might add that. I control it with BIOS because, like, come on. It's, I mean, even BIOS is weird, it's not really the best. Now, if we here click X, you'll see we still have our PWMs set because we have delay of slowing down, and now we are slowing down. Like, we were waiting for our system a little bit to cool down. We have said that it's a feature. Now also same thing with Furmark. You can throw a GPU. You can see we'll be ramping up in a second. Our GPU is here. Yeah, we are ramping up. And my system is getting louder. While GPU temperature 71, hotspot 84. We are really ramping now. And now, yeah, I might set better curves, more extreme for GPU, because like, maybe I need to repaste it, or maybe I could turn off my proportional control, it will be better. Now you can see we are staying still at higher RPM, and we are even right now dropping because we need to cool still our system a little bit more. Although GPU did follow kinda slow curve for stopping, as you can see by that fan. So our cooling is still like our delay is still not great enough for GPU, like maybe 20 seconds, because it kinda did follow our yeah, GPU did kinda slowly decline its temperature, as you can see also here. So yeah, this is my software. Still need to write instructions, upload new config file into our git readme. I need to update. It's still from Linux, which on Windows it's totally different. We'll do that. For now I just wanted to put out the message that I'm happy I wrote an app. Okay, thank you for watching. Have a blessed day.